Okay, so what we're looking at here is a problem where we're trying to solve a compound, um, essentially two inequalities. So we have negative x plus 10 is greater than 11, and 7 plus 2x is less than or equal to negative 1. Okay, so what we want to do is we want to start out by solving each of these independently, solving for x. So let's look at this first one right here. We want to get the x by itself, so we're going to subtract 10 from both sides, and that leaves us with minus x is greater than what? Okay, we want to get rid of the negative sign in front of the x, so you can divide both sides by 1, or you can multiply both sides by 1. I always like multiplying. You can multiply both sides by 1, but what we have to remember to do is we have to flip the sign. And that's just something that we always have to do. When you have an inequality and you're multiplying or dividing by a negative number, whenever you do that, you have to flip that sign. And by flip that sign, what I mean is now on the left we have x, but in the center, the new thing that we have instead of having a greater than sign is we have a less than sign. So now we have this is less than negative 1. So what we can do is go in here and make a little number line and kind of take a look at what this is going to look like. Since this is a less than sign, that means I'm going to use my little parentheses here. And since it's a left-hand sign, I'm going to use my parentheses, and I want to go all the way to the left. So what I'm saying by doing this graph here is that, like, this one would be negative 2, right? So negative 2 is less than negative 1, and over here, negative 3, that's less than negative 1. So all of these points over here are in fact less than 1. And if you ever wonder what direction you're supposed to draw your arrows, we always go in the direction that the arrow points us to go. Okay, so get rid of that. So now we come over here to solve this other one. So again, we want to get the x by itself. So I'm going to subtract 7 from both sides. So I've got 2x is less than or equal to minus 1 minus 7, which is minus 8. Now I'm going to divide both sides by 2. Now I don't flip the sign because I'm dividing by a positive number. If I've been dividing by a negative number, then yeah, I'd go ahead and flip the sign. But because this here is positive 2, so don't flip the sign. Okay? So 2x divided by 2 is just going to be my x, less than or equal to negative 8 divided by 2, which is negative 4. Alright, so now I want to draw this one. 0, 1, 2, 3, 4. Okay, so in order to do this one, I'm looking for where x is less than or equal to negative 4. Well, again, I follow the direction of the arrow. It's less than or equal to, so that means I'm going to use my bracket, and I'm going to go all the way off to the left. Oops, did not mean to do that. My bracket, and I'm going to go to the left. So this is how I would graph just that. Now, where it can get a little confusing is that how do we combine these two graphs? Well, what it is that I go ahead and look at my original problem. And my original problem said and. What and means is I have to meet both conditions. So we'll go ahead and write that in here. And I have to meet both conditions. Both of them. So I have to be less than negative 1. So I have to be less than negative 1. And I also have to be less than or equal to negative 4. So I just can start investigating individual points, okay? Because, well, none of these points over here are going to work. None of these points are going to work because they don't meet this condition at all. So let's just start off by testing. Let's test negative 2. So negative 2 works over here, but what about over here? No. See, negative 2 isn't included over here. even though it's included here, it doesn't matter because it has to meet both our conditions. Similarly, if we take a look at 3, or -3, it works here, but over here, no, because we have a -3 on this side, but over here in this condition, -3 does not meet that requirement. So what's going to turn out is, if you take a look at this, you're always going to go with whatever, for the and statements at least, you're always going to go with whatever is most constrictive. So whatever is most restrictive. You see? Because even though over here, -2 would be fine, over here, I don't include -2. Same thing over here, -3 works, but over here, -3 isn't okay for this guy. So if I'm going to find a solution that meets both of those equations, both of those inequalities, the only way to do it is to say, okay, well, it turns out that after all, this one right here is the more restrictive, is the more, is the more restrictive one that I have to worry about. Because if you take a look, if I say, okay, well, you know, -4 works here, and in fact, -4 does work over here. So this is really what's going to define that space, because it's more picky. If you're trying to figure out where you want to go to the restaurant, this guy, he's pretty much okay with anything, you know, south of this direction. This guy, though, he's a lot more specific. So we have to meet his requirements, because unfortunately, he's just more picky than the other guy. So that's how we're going to solve these problems, is we're going to take a look and find, especially if they're facing the same direction, that makes it a lot harder. You got to figure out which one is more picky. So if you're looking to write this in interval notation, remember, since this is going off to -infinity, we'll write -infinity with our parenthesis, which kind of indicates a, you know, we can't exactly get to infinity, but we can get really close. So parentheses, -infinity, comma, -4, and we pull the notation directly off of our graph. So maybe that'll give you some help. Enjoy.